This semiconductor MCQ is from NEST 2020, second shift, question 6. This is similar to that black body radiation and band gap problem. The remote control of a TV emits infrared light of wavelength 900 nanometers. The TV detector is made of a semiconductor whose band gap is X electron volts. The detector is shielded by a semiconductor optical fiber whose band gap is Y electron volts. From the 4 options below, select the best option for the TV to function. X 1.2, Y 1.4, X 1.1, Y 1.8, X 2.2, Y 1.0, X 2.0 and Y 1.2. Okay. Now first thing that you must understand is, for the TV detector, okay, so let me put in this way, for the TV to detect the signal from the remote control, the band gap that is X, the band gap that is X in electron volts should be less than the energy that the photon gives. Raise your hands if you understand this. Right? Only then it is able to excite and convey the signal, to change the channel or to increase or decrease the volume or to turn it off. Okay, fine. So let's now calculate the energy that the 900 nanometer wavelength light is going to have. 6.626 into 10 raised to negative 34. C is 10 raised to 3 into 10 raised to 8 upon lambda. 900 into 10 raised to negative 9, and of course because it is in electron volts we must divide this by 1.6 into 10 raised to negative 19. Let's do it in two parts. First let us calculate 6.626 into 3 upon 900 into 1.6, that's 0.0138. okay, that's 0.0138. Now let us calculate the powers. Minus 34 plus 8 plus 9 plus 19, that's 2. Okay, powers of 2, so that makes it 1.38. okay, that makes it 1.38. now look, will C and D be acceptable? No, C and D will not be acceptable. Why C and D will not be acceptable? Because there the band gap is greater than what the IR photon has to offer. Have you understood this? Yes, okay. So we can approximate it as 1.4 now, because otherwise we will not be able to conclude whether it is option A and B. Here is how. Now look, let's now go to that shield part. Okay, let's now go to that shield part. Okay. Now for the shield part we can argue like this. Shield is usually the upper bound. Okay, do you realize that? So beyond that it will not permit. Okay, beyond that it will not permit, or we can also say that this is precisely the same frequency, or let's say a gate. A particular frequency is only permitted. Okay, a particular frequency is permitted. Now, although if we apply the logic of upper bound, then both A and B will match. Okay, both A and B will match. But that 1.8 will also leave possibility of some other radiation triggering the TV, and we don't want that to happen, right? 1.8 electron volts may trigger the TV due to some signal, not necessarily from remote, okay. So it's better to take it as close to the incident energy as possible, okay, or photon, okay. Therefore better to choose y equal to 1.4 to be a good shield or filter. Okay, all right.